All right, guys, so this is the final ed puzzle of this chapter 9, and we're going to talk about angle of elevation and depression. So there's two different things we're going to paste into our interactive student notebook. The first is just kind of a half page that looks like this. It's just kind of a visual of what we're going to talk about. So the angle of elevation is the angle formed by the horizontal line and an observer's line of sight. Okay, so there's two keywords here. Horizontal line. Okay, and here's a horizontal line, and here's a horizontal line. And then the other one is the observer's line of sight. So we're either going to look up at something or we're going to look down at something. In this case, we're looking up at something. So the angle of elevation is the angle formed when we're looking, so elevate when we're looking up, so we're using this line of sight, and we're going to go to this horizontal line. Okay, so if we look straight, would be here. If we look up, would be here. So the angle of elevation would be this angle right here. Okay. Now the angle of depression is kind of same but opposite. And so if we're going from a horizontal line and here we're looking downwards, so we're looking down, this would be the angle of depression right here. Okay. So the angle of depression is the angle formed by the horizontal line and the observer's line of sight to the object below. Okay. All right, now let's look at this foldable. Okay, so on the front, you should fold it in half and then cut the flap. So under the angle of elevation flap, when you open it up, you should see this picture right here on the right. Okay, so an angle of elevation, like we just said, when looking up at an object, okay, we're looking up. The angle of elevation is formed by the observer's line of sight and a horizontal line. Okay, so here's our horizontal line and here's our line of sight looking up. And the angle formed when we do that is right here. So this in green is our angle of elevation. All right, so let's do this example problem here, number 1. Okay, we have 2 total. Here's number 1. So it says a dog is standing. So here's our dog right here. A dog is standing 5 feet from the base of a tree. So here's a tree, and the dog is standing 5 feet from the base. And we know that trees go up at a 90-degree angle. What is the angle of elevation? So if the dog's looking up, I should have had its head on the other end. That's okay. If the dog's looking up, what is the angle of elevation, which is this angle right here, from the point the dog is standing on the ground to the cat in the tree, and notice the cat in the tree is 16 feet up. Okay, so here's our picture. So if I kind of draw this over here without all the unnecessary stuff, we have a triangle. Here's a right angle. This is 5 foot. This is 16 foot. And we want to find this angle. Okay. Now, because we're looking for an angle, that means we're going to use inverse. So inverse sine, cosine, or tangent. So this is our reference angle. So this is our opposite side. Here's our hypotenuse, which means this has to be adjacent. Okay. I know my opposite and I know my adjacent. So if I have so, ka, toa, I want to ask myself what pairs O and A together. O and A is together right there in tangent, so I'm going to use tangent. So I can say the tangent of our unknown angle equals opposite over adjacent. So tangent of theta equals, well, opposite is 16 over adjacent is 5. So because I want the angle, I'm going to use inverse. So my tangent inverse, and when I use inverse, these two are flopped. Okay, of 16 over 5 equals theta. And if I put just tangent inverse of 16 over 5 in my calculator, we should get roughly that theta is about 72.6 degrees. All right, let's look at example 2 now. It says the angle of elevation from a soccer ball on the ground. Okay, so here's the ground. Here's our soccer ball. To the top of the goal, here's our goal post right here, is 34 degrees. And guys, this should be straight up and down, 90-degree angle. If the goal is 8 foot tall, so it's 8 foot tall over here, okay, we want to know what is the distance from the ball to the goal. So that would be this distance here. What is it? I'm just going to call it X. Okay, so if you want to draw this without the added stuff, we have 34 degrees, a right angle, we have 8, and we have X. Okay, so if I label each of these sides, opposite of our reference angle is O. This is my hypotenuse, this is my adjacent. So I know my O, I want to know my A. So if I write SOHCAHTOA at the top here, what pairs O and A together? O and A are together right there, so I would once again use tangent. So tangent of theta is opposite over adjacent. Okay, now let's plug in stuff in. Okay, so in this case, tangent of, I know my angle measure is 34 degrees. Tangent of 34 degrees equals opposite, which is 8, over adjacent, which is X. Okay, now I'm not looking for an angle here, so I'm just going to use regular sine, cosine, tangent. I'm not going to use inverse. Okay, so from here, to get rid of a fraction, I always multiply both sides by X, and when I do that, these cancel each other out. So X times tangent, 34 degrees, equals 8. And if I divide both sides by tangent, 34 degrees, divide by tangent, 34 degrees. Remember, this tangent of 34 degrees, it's just a number. If you wanted to plug that in here, you could have done that, okay? So what I get is X equals 8 over tangent 34 degrees. But if you do it this way, if you don't plug it in at first, you don't have to worry about rounding it or retyping it in. So if I put just this into my calculator, I get roughly 11.86-ish, and that's feet. All right, let's go down to our second flap, which is angle of depression. Okay, so if we open that flap up, we see this picture right here. And here we're looking down at an object. Okay, so the angle of depression is formed by an observer's line of sight and a horizontal line. Okay, so if I look at this picture, here's a horizontal line, and here's our line of sight. We're looking down on something. So the angle of depression is the angle formed by those two, which is right here. Okay? Okay, now this is kind of a big thing here. So if I have an angle of depression, so here, and I'm going down. And if I draw that with an angle of elevation, it's here going up. The angle of depression and the angle of elevation are always congruent. Okay, and they're always congruent because these horizontal lines are parallel, and therefore the angle of elevation and the angle of depression are alternate interior angles. And as we learned back in chapter 3, I believe, alternate interior angles are always congruent when the lines are parallel. All right, so let's look at example 3 now. It says the angle of depression from an angle setting on top of the flagpole. So here's a flagpole, here's an eagle. It's on the top of the flagpole. To the base of a tree. So if he's looking here to the base of the tree, so the bottom part of the tree, is 63 degrees. Now, a lot of times people want to say, oh, that means this is 63 degrees. That is not correct. Okay, remember, the angle of depression has to be from a horizontal line looking downwards. Okay, so this here is 63 degrees. Okay, now, if this is 63 degrees here, that means this has to be 63 degrees as well because these are alternate interior angles. Okay, so if I wanted, well, actually, let's finish it. The flagpole's 18 foot tall. So here's 18 foot tall. What is the distance between the flagpole and the tree? So we want to know this distance here. Okay, so if I draw this without all the unnecessary stuff, I'd have this right triangle. This is 63 degrees. This is X, and this is 18 foot. All right, so if I label each one of these sides, this is my opposite side. Opposite of right is my hypotenuse. The one left over is adjacent. I know my, or I want to know my adjacent. I know my opposite. So, Toa. So ask yourself, where does A and O get paired up here? A and O get paired right here. So I can say the tangent of my angle, which is 63 degrees, equals opposite over adjacent, which is 18 over X. Okay, now once again, we have a fraction. To get rid of it, I multiply both sides by the denominator. So I have X times tangent 63 degrees equals 18. And once again, if you want to go ahead and put tangent 63 and put a number there, that's okay. Personally, I just like to wait so I don't have to worry about retyping it in. Okay, get X by itself, you multiply by tangent of 63 degrees on both sides. So X equals, those go away, 18 over tangent 63 degrees. And if you just put this in your calculator, you get that X is roughly 9.2 feet. All right, I'm going to help you try this one, or I'm going to help you draw this one out, and then you're going to try it on your own. So it says a shark is swimming 28 feet below sea level. So if here's our sea, the shark is 28 feet. Okay, so here's the shark. If the angle of depression from a boat, so here's our boat, we'll make it a sailboat. If the angle of depression, so if we look down from the boat, is 19 degrees, what is the horizontal distance? Remember, horizontal is left, right. What is the horizontal distance between the boat and the shark? So we want this here. Okay, I want you to go ahead, do the math, and solve this problem, and then we'll go over it. All right, so after you label each of these sides, once again, we know our O and our A, so we will use tangent. Okay, so tangent of any angle is always opposite over adjacent. So when we set it up, you should get tangent of 19 equals 28 over X. To get rid of the fraction, let's multiply X on both sides of the equation. And once we do that, we get X times tangent 19 equals 28. Divide both sides by tangent 19, or if you've already made this into a number, divide by that number, that's okay too. And what you get is X equals 28 over tangent of 19, and you just throw that into your calculator. 28 divided by tangent of 19, and you should get X is roughly 81.3 feet, which is your final answer. Now, I know all of our questions on here dealt with tangent. They won't always be that way. You can use sine and cosine as well with angle of elevation and depression. That's just how it fell this time.